Okay, we're asked to find the angle between a pair of vectors, and we have a formula for that. It is cosine theta equals u times v, where these are vectors, then the magnitude of u times the magnitude of v. So what does this mean? So in the top, this times this, and then down here, the magnitude of each of these. Now, to find the top, this is going to be the dot product. And so the dot product, remember, is those two times those two plus each other. So the top's going to be 1 times 1 plus 7 times 1. And then in the bottom, the magnitude, and this is our formula, is we're going to simply add up the squares. So then I have 1 squared plus 1 squared. So that's 1 plus 7, that's 8. This is 50, 49 plus 1, and that's 2 plus 1 plus 1, which is 2. So this is 8 over the square root of 100, because I can collapse those by radical rules. So 8 over 10, or 0.8. And then at this point, we're simply going to plug this into our calculator to find theta. So I'm going to do the inverse cosine of 0.8. Make sure you're in degrees. And I'm going to get 36.9 degrees. So this angle is about 37 degrees. So if I was asked if this was orthogonal, it would be no, because it's not 90 degrees. Okay, let me do a second one here. So this one here, same thing, same process. We are going to use our formula again. So in the top, cosine theta, the dot product of these two, which is going to be 1 times 1 plus 1 times negative 1, all over 1 squared plus negative 1. No, I'm on the next one. This is just 1 squared. I guess it doesn't really matter. And then 1 squared plus negative 1 squared. So in the top, that's 1 plus negative 1. That's 0 over the square root of 2 times square root of 2. Well, anything divided by 0 is 0. And then at this point, I go, okay, well, the cosine of theta, well, theta has to be 90 degrees. So this is orthogonal. This is a right angle. And so that's all there is to this. It's really just a formula that uses all the bits and pieces, which is kind of cool because we can then, feel like, oh, we got to use everything. We got to use our dot product. We got to use our magnitude, and as well as our new cool vocabulary term.